Hello students, and welcome to Chemistry B. I'm Ms. Slate, and today we're going to talk about how stoichiometry and mole conversions relate to chemical reactions. First off, the main point of stoichiometry and the whole mole conversion process is so that you can predict the amount of a product or a reactant needed in a chemical reaction. So if I want to know if I've got 10 grams of X and 10 grams of Y, how much of the product is going to be produced, whether that's in terms of mass or volume or particles. That is what stoichiometry is really for. And so that's what we're going to start working on. We'll use the production of ammonia as our example. So before you start any kind of stoichiometry problem, you need to make sure you have a balanced chemical equation. So hydrogen is H2. Nitrogen is also diatomic, N2. And ammonia is NH3. To balance this chemical equation, I need to double my amount of ammonia and triple my amount of hydrogen. Because again, this is telling us what ratio these molecules are reacting in. Remember, this is really telling me that I have 3 hydrogen molecules reacting with just 1 nitrogen molecule that is then at the end forming 2 ammonia molecules. So we always have to start with the balanced chemical equation. So let's look at a specific example, which is how many moles of ammonia are produced from 3.5 moles of nitrogen gas. Again, I'm just going to jot down our balanced chemical equation. And to help us kind of think through this process, it's helpful to look at an expanded mole diagram. So if you pull out your mole diagram worksheet and you flip it over to the back, you should see what's called the expanded mole diagram. It's similar to the normal mole diagram, except now we have substance A and substance B. So anytime we want to know how much of A will produce how much of B, we do that conversion in moles, okay? So it doesn't matter whether we're starting with mass, volume, or particles. Before we can figure out how much of A will make how much of B, we need to make sure we convert moles. And the way we convert between substance A and substance B is by using the mole ratio, which the mole ratio is based off the coefficients in the chemical equation. So if we go back to this example, it says how many moles of ammonia are produced from 3.5 moles of nitrogen gas. So what we're doing is we're going from moles of A to moles of B. And again, our conversion factor between 2 different substances is their mole ratio from the chemical formula. So if we go back here, remember, we can imagine there's a coefficient of 1 written right there, and 2. So our mole ratio of nitrogen to ammonia is 1 to 2. And so that's going to be the conversion factor that we're going to use here, okay? So we're going to start like normal. I'm going to write down what I have, 3.5 moles of nitrogen gas. When you are doing stoichiometry and reactions, you must label what substance you are working with, okay? Your conversions are not going to make sense if you don't label the substance. So we're at the point where you need to be labeling what substance you're working with. So I need to make sure that I label it 3.5 moles of nitrogen gas. Now, I have moles of nitrogen gas, and I want to cancel that. So that's what I'm going to put on the bottom of this conversion factor. What I want are moles of ammonia. So I'm going to put moles of ammonia on the top. Again, the conversion factor here is their mole ratio, where we have 1 mole of nitrogen to 2 moles of ammonia. So I put the 2 next to moles of ammonia and the 1 next to moles of nitrogen. And my moles of nitrogen will cancel with each other, and I'll be left with just moles of ammonia. And when we double 3.5, we get 7 as our answer, and I'll make it 7.0 so that I have correct significant figures. And that's how we use a mole ratio that comes from our balanced chemical equation to convert from moles of one substance to moles of another. Now let's look at a slightly more complicated example, okay? So we're still going to use the same equation, the production of ammonia, but this time it says how many hydrogen molecules must react to form 200 ammonia molecules. So let's look at our expanded mole diagram here, okay? So we want to go from particles of hydrogen to particles of ammonia. Well, the first thing we're going to have to do is convert from particles to moles, then convert from moles of one substance to moles of the other using the mole ratio from the coefficients of the balanced chemical equation. Once we have moles, then we can convert back to particles, okay? So there's kind of like couple steps to this. So let's take it part by part. First part, we're going to convert from molecules of ammonia to moles. Again, like I said, you must be labeling what substance you are dealing with. So it's not enough for me to just label it 200 molecules. I need to label it 200 molecules of NH3. And the first thing I'm going to do is convert that to moles, where 1 mole is equal to 6.02 times 10 to the 23rd molecules. At this point, molecules cancel, and I have moles of ammonia, okay? So what we've done is we've gone from particles of ammonia to moles. Now we're going to go from moles of ammonia to moles of hydrogen using the coefficients from the balanced equation for our mole ratio. If we look at our mole ratio here, we have 3 moles of hydrogen to 2 moles of ammonia. So first off, I have moles of ammonia. I want to cancel that, so moles of ammonia will go on the bottom. I want moles of hydrogen, so moles of hydrogen will go on the top. Again, our mole ratio is 3 moles hydrogen to 2 moles nitrogen. So I'm going to put a 3 moles next to hydrogen and a 2 moles next to ammonia. At this point, moles of ammonia cancel, and I'm left with moles of hydrogen. So at this point on the mole diagram, we have converted from moles of ammonia to moles of hydrogen, and now we're just going to need to multiply by Avogadro's number to get back to molecules of hydrogen. So in 1 mole of hydrogen, there's going to be 6.02 times 10 to the 23rd molecules. And moles of hydrogen cancel, and I'm left with just molecules of hydrogen. So now we just do the math and get our final answer. And it's going to come out to 300 molecules of hydrogen. And that's how we can use stoichiometry and the mole ratio from a balanced chemical equation to figure out how much of a product will be produced or how much of a reactant will be needed.